This is lesson 3.1 for Foundations in Pre-Cal 10, starting on page 123. This is going to be pretty quick because this is definitely review what we're doing today, but there's lots of new stuff coming. Just some vocabulary in algebra. A variable is a letter that represents a number that we just don't know at this point. An expression is some kind of combination of letters and or numbers, like that. So an expression is something like that. And an equation has an equal sign. That's the difference, okay? These are called algebraic expressions because they have variables in them. You could have a plain expression that could be like 2 plus 3. That's an expression. And then if I make that equal 5, now I have an equation, okay? Polynomials we're going to get into, okay? A monomial is a number or a variable or a combination of the product of numbers and variables where the exponent on any variable must be a positive integer in the numerator of the monomial. So that means that these are monomials, all of these things that we normally see. How about a non-monomial? These are non-examples. 1 over x, m to the minus 2, m to the 3/4, okay? Because here our exponent, our variable is in the denominator. Here our variable has a negative exponent, and here it's a non-integer exponent, okay? So those are all non-monomials. The coefficient or the numerical coefficient is whatever we're multiplying something by. So in this one, it's going to be 2. In this ABC, there's a coefficient of 1 there that's invisible. 0.25 is our exponent, or sorry, our coefficient there. If I had negative x, my coefficient would be -1 is the coefficient because there's an invisible 1 there as well, okay? And a polynomial is a sum. Now, I define this, I give a different definition. I want you to think about this as a polynomial as just the sum of monomials, because anytime you have a difference, you can actually write this as x squared plus -5x plus -9. And life is a lot better for you if you keep this negative sign that it belongs to the 9. So that's a term. And this is a term, and they're all connected by addition, whether there's an addition sign in there or not, because when we have a subtraction, that we could think of that as plus negative. Okay, number example 1. Why is this not a polynomial? Because we have the variable in denominator. Okay. And now we're going to talk about classifying polynomials. So there's 2 ways that we can classify them. One is by the number of terms that it has, and one is by the degree of the polynomial. So let's look at that. If we talk about classifying by the number of terms, remember, when there's more than one term, they're connected by, we're just going to go by plus signs because you can always rewrite it. You can always rewrite it with plus signs, and that just makes things better. So if it has 1 term, it's a monomial. If it has 2 terms, it's a binomial, think bicycle. And a trinomial has 3 terms, think tricycle. And if it's anything more than that, we just call it a polynomial, although monomial, binomial, and trinomial are also polynomials, but we have no special name for anything with 4 or more terms. Okay, some more questions here. Consider these expressions. In each case, state whether this represents a polynomial or not. If it's not, say why. And if it is a polynomial, is it a monomial, binomial, trinomial? Okay. So, is this a binomial? Or sorry, is this a polynomial? Yes. Let's just go through. No, let's do this way. Okay. And since it is a polynomial, is it a monomial, binomial, trinomial? This is a binomial. Number B, is this a polynomial? No, because we have a non-integer exponent. Oops, x. Where did that t come from? Exponent on the variable. Now, it's really important that that's on the variable, because if I had, for example, if I had 9 to the 1/2 x, y, that is a polynomial, because 9 to the 1/2 it actually just means 3, which you'll do next year, but we only care about the exponents on the variables, okay? C, yes, this is a polynomial because there's nothing that makes it not, and it is a trinomial because it has 3 terms. D, this is not, because we have a non-integer or non-positive integer exponent on the variable, and this one is a no because we have the exponent in the denominator. Okay, we are going to do this. I'm going to suggest that you pause the video, fill this one in by yourself, and then check your answers on this. Okay. Okay, not sure why they're asking for the number of variables here, because the number of variables has nothing to do with how many terms it is or what the classification of by number of terms is. It has nothing to do with that. Okay, all right, next page. Classifying polynomials by the degree of the polynomial. So the degree of the polynomial and the degree of the term is very confusing. If you have trouble with this, I have some extra practice for you that makes it, I think, a little more clear than what they have here. We have to start with the degree of a monomial, and that is the sum of the exponents on the variables. Again, we don't care about the exponents on the numbers, but just the variables. So this one here, 2x to the 5, has degree 5 because 5 is the exponent on the variable. The second one here, there's that, but there's also a 1 on a. We could have written that as a to the 1 b cubed c squared. So this has degree 1 plus 3 plus 2 is 6. So that's the degree of that term. All right. And then if we have something, just a whole number, has degree 0. Okay, so if there's a monomial with no variable, the degree is 0. All right. So here we go. Oh, and then the degree of the polynomial, you have to find the degree of each term, and then it's the highest of those. So this term has degree 4. This term has degree 4. This term has degree 5.
Grade 9 students wanting to have photo retakes last name G through L, please text the leader. That's grade 9 students wanting photo retakes last name G through L, please text the leader.
This last term here has degree 0 because it doesn't have any variables at all. So the degree of this polynomial is the highest of these numbers, which is 5. And if there's a term that has no variable present, we call that the constant term because it is constant, it doesn't change, and in this one it's -2. All right, see how I included the negative sign with the 2 because those go together. All right, okay, let's, why don't you take a try at this, doing the degrees of these polynomials. pause it and then come back and check your answers. All right, I hope you got those right. I'm just going to skip this question because it's boring. I don't think it's important. Okay, here's some vocabulary for classifying polynomials by the degree of the polynomial. So a constant polynomial is just a number. Linear polynomial has degree of 1. So for example, x plus 3. Quadratic has a degree of 2. That seems kind of weird because quad sounds like 4, but this is one you'll do a lot of that in grade 11. Whoops, this is gone crazy. Okay. So a one with a degree of 2 is a quadratic polynomial. Cubic is degree of 3. Quartic polynomial is degree of 4, and quintic is 5. What is my? Oh shoot. Okay. Let's fill in this table. So we've got a polynomial expression here. There's a 1 there and a 1 there. So 4xy has a degree of 2. Negative 6 has a degree of 0. So this has a degree of 2. So this is a quadratic. And the constant term here is negative 6. Second example, this has got a degree of 2. This has got a degree of 3. So the degree of the polynomial is 3. So this is a cubic. And the constant term, there is not 1. Okay, and that symbol here, that refers to the empty set. And it's a 0 with a line through it at a diagonal, and it means there's no solution there. There's solutions, there's none. Okay, almost finished this video. When we have polynomials that have a single variable, we usually arrange them in descending. It's usually in descending order of the power of the variable. So in this example, we're going to do this in descending order. So the highest degree is this one, so this would be minus 4x cubed. Then if we have something with a square, it's this, and that's going to be plus 6x squared over 5, and then plus 2x, because there is an invisible plus out here, and then minus 7. So that's it in descending powers of x. If we were to write it in ascending or increasing powers of x, it would be minus 7 plus 2x plus 6x squared. Oops. Okay, plus 6x squared over 5 minus 4x cubed. And the leading coefficient is the one with the highest power of the variable. So it's going to be the minus 4x cubed is the term, and the coefficient is negative 4. Okay, so this is why I talk about polynomials as being monomials connected by plus, because if there's the minus always belongs to what comes after it. So if you're thinking about if you're thinking about this as being connected by plus or minus, then you might think of the coefficient as 4, but really the coefficient is negative 4, and that's a much better plan. Okay. So I guess I should write this down here. The leading coefficient is negative 4. And the constant term is just the number by itself, which is going to be negative 7. And again, the negative comes with it. And the numerical coefficient of the term with x squared, that's this one. So the coefficient is 6 over 5, okay, because that's the numerical portion of it. And actually up here, I could have written this as 6 over 5 times x squared. Those are equivalent, okay? Just in some contexts, it makes more sense to write it one way rather than the other way. Okay, that is the end of video 1.